Hello children, in the previous class we learnt about distance time graphs and how to calculate speed from the slope of distance time graph. Today we will learn about speed time graphs or velocity time graphs. So for moving objects we can have these types of speed time graphs or velocity time graphs. When the speed or the velocity of the object remains constant, means there is no change in the speed. When the speed of the object changes at uniform rate, means at regular intervals the speed also keeps on changing, increasing or decreasing. And when the speed of the object changes at non-uniform rate. So in the first case, when the speed time graph is plotted for an object whose speed is constant. So when the speed of an object is constant or uniform, we know that the speed does not change with time. Then the graph for such a moving object will be a straight line which is parallel to the time axis or the x-axis. We already saw that time being an independent variable is represented on the x-axis, and here speed or velocity will be represented on the y-axis, and it is a dependent variable. So when the speed is uniform, then the speed time graph will be a parallel line to the time axis. Or if we see a graph like this, we can say that the object is a straight line. If it is a straight line parallel to the time axis, then through this we can infer that the speed of the object is constant. Means it does not change with time. So remember, from these speed time graphs or velocity time graphs, two quantities can be calculated. If you think about the formulas, different formulas we have learnt, we already saw that speed is equal to distance by time. And another quantity which involves both velocity and time is acceleration. Acceleration is nothing but rate of change of velocity with time. So the slope of a speed time graph gives you the acceleration, and the area of a speed time or a velocity time graph gives you the distance covered by the object. So you can see here the graph plotted for an object moving with uniform speed or uniform velocity. So this line is a parallel line to the time axis. In case we have to calculate the distance traveled by this object at the time interval t1 to t2, we know that speed equal to distance by time. So from the same formula we can say that distance is equal to speed into time. So here if you see, we have the values of velocity or speed of the object, and we also have the time interval. So in case we have to calculate the distance between t1 and t2, then we have to calculate it using the formula speed into time. So here if you see, the speed is nothing but from 0 to the line, parallel line, which is 40 meter per second, and the time interval is t2 minus t1, which is 12 minus 6. So I can say that speed equal to distance by time. From here we know that distance is equal to speed or velocity into time. If you see the graph here, the value of velocity will be, if you take from 0, the origin, the value is 40 meter per second. And the time interval between t1, we are only going to calculate the distance between t1 and t2. So the time interval t2 minus t1 is 12 minus 6, which is 6. The value will be 240 meter. So the distance travelled between t2 and t1 or from t1 to t2 is 240 meter. If you again see the formula here, this actually is a rectangle, and we have calculated the distance as V into T, that is the length into breadth. So distance can be calculated by calculating the area of this rectangle. Here once again it is explained to you. We have taken the same graph where the object travels with uniform speed. So speed at the point B is given by the line BC, and speed at the point A is given by the line AD. We know that by looking at the diagram, since it's a parallel line to the time axis, we know that AD and BC, both the values are same, which is equal to V, which is the velocity of that object in motion. And the time interval AB is nothing but T2 minus T1. So distance covered by the object in time interval T2 minus T1 is given by V equal to V into T2 minus T1, which is nothing but AD into AB, or the area of the rectangle ABCD.